All right. So adding a little bit more to our hypothesis testing pool of information here. So when we eventually start hypothesis testing, which we're not quite there yet, 7.2 is when we're actually going to do all that, we will always start by assuming that our null hypothesis is true. So yesterday we practiced just writing a null hypothesis or our other hypothesis, our alternative hypothesis, determining which one is the claim. And then now that we know which one is which, we're going to assume that's true at the start of all of our tests. Two things will happen after you complete a hypothesis test. You will either reject the null hypothesis or you will not reject the null hypothesis. You will choose to not reject it. So that's kind of a weird wording. You're going to see that a lot. You might even see the words fail to reject. I don't love that wording as much. But when we say do not reject, it's almost like we're accepting it, but we technically with statistics do not have enough information to accept ever a null hypothesis. So we either have enough information to reject something that we are assuming is true, or we do not reject it, which is almost like agreeing to whatever the claim is, but not quite. All right, because your decision is always going to be based on a sample, not the actual population, there is always a possibility that you will be wrong with whatever decision you make. And that will cause either what we call a type 1 or a type 2 error. So the first part of our lesson today, we're going to focus on what a type 1 and type 2 error are. So a type 1 error is if the null hypothesis, which we are assuming to be true, actually is true, but we reject it. Okay, so something that is true in real life, actually happening, but we reject it. We have information from our sample that tells us it's not actually true. You should reject whatever that claim is. Type 2 error is if the null hypothesis is actually false in real life, but you do not reject it. So you are essentially accepting something that is not true. There's a nice little chart of this at the bottom. So at the top, you've got the truth of whatever your null hypothesis is. It's either true or false in real life. And then your two choices, either do not reject it or do reject it. If something is true and you do not reject it, the correct decision has been made. Or if something is false and you do reject it, the correct decision has been made. If something is true and you reject it, that's a type 1 error. If something is actually false, you do not reject it, that is a type 2 error. So on the next page, we're going to see some examples of this so you can kind of wrap your head around it. A very common example when you look up type 1 and type 2 errors in statistics is innocent until proven guilty. So here the null hypothesis is that a defendant is innocent. So we assume that someone is innocent until we prove them guilty. So at the top, we've got the truth in reality of whatever this defendant did. So this person is either innocent or guilty of their crime. And then on the side are the verdicts that can be made from the jury, either not guilty or guilty. So if someone is innocent and the jury finds them not guilty, is that an error? If someone is innocent and the jury finds them not guilty, is that an error? No, justice has been served. Okay, what if somebody is guilty and the jury finds them guilty? Not an error, right? That's the correct decision. So justice has been served. If someone is innocent in real life but found guilty, that's an error. That's what we call a type 1 error. Okay, so the truth is that person is innocent, but they have been found guilty. And then if somebody is guilty and they are found not guilty, type 2 error. So they kind of almost use this wording in the justice system too. They don't say guilty and innocent when they prove someone one way or the other, right? Guilty and not guilty. So think about that when you're thinking about rejecting and not rejecting. That's why they use that wording. Okay, we're going to fill out the next one together here. So real life example for everyone. You are COVID-19 negative. Yay. Okay, so on top, we're going to put our COVID-19 status, whatever that is. And so two things can happen. Either our null hypothesis is true or our null hypothesis is false. If our null hypothesis is true, you are negative. If our null hypothesis is false, you would then be positive. Okay. Now, how do we determine what your COVID-19 status is? We do a test. So, test results can be one of two things. They can either be negative, which will represent us not rejecting the null hypothesis, or positive, which means we will reject what we are assuming to be true, the null hypothesis. Okay, so if you are COVID-19 negative and you take a test and the test says you are negative, is that accurate? Yes. If you have COVID-19 and you take a test and the test says you are COVID-19 positive, is that accurate? Yes. If you do not have COVID-19, but the test says you are positive, is that accurate? No. So that is a type 1 error, which in medical terms, they're going to use the word, and you guys have probably heard this, false positive is another way of thinking about a type 1 error. It's a false positive. And if you are actually positive, but the test says you're negative, that's a type 2 error. And what is that called in the medical community? It's a false negative. Okay, so obviously we want to minimize these errors as much as possible. So we'll talk about that in a little bit, how we set our percentages to be very low for the chance of these errors to occur. All right, I have a cute little video for you. I think it's a cute little video anyway. Let's see if it plays. Come on. About type 1 and type 2 errors.
Having trouble choosing a boot camp to start your career in data science? Try Practicum's Data Science.
In this lesson, we will learn about the errors that can be made in hypothesis testing. In general, we can have two types of errors, type 1 error and type 2 error. Sounds a bit boring, but this will be a fun lecture, I promise. First, we will define the problems, and then we will see some interesting examples. Type 1 error is when you reject a true null hypothesis and is the more serious error. It is also called a false positive. The probability of making this error is alpha, the level of significance. Since you, the researcher, choose the alpha, the responsibility for making this error lies solely on you. Type 2, accept a false null hypothesis. The probability of making this error is denoted by beta. Beta depends mainly on sample size and population variance. So if your topic is difficult to test due to hard sampling or has high variability, it is more likely to make this type of error. As you can imagine, if the data set is hard to test, it is not your fault, so type 2 error is considered a smaller problem. We should also mention that the probability of rejecting a false null hypothesis is equal to 1 minus beta. This is the researcher's goal, to reject a false null hypothesis. Therefore, 1 minus beta is called the power of the test. Generally, researchers increase the power of a test by increasing the sample size. This is a common table statisticians use to summarize the types of errors. Now, let's see an example that I heard from my professor back when I was studying statistics in university. You are in love with this girl from the other class, but are unsure if she likes you. There are two errors you can make. First, if she likes you back and you don't invite her out, you are making the type 1 error. The null hypothesis in this situation is, she likes you back. It turns out that she really did like you back. Unfortunately, you did not invite her out because after testing the situation, you wrongly thought the null hypothesis was false. In other words, you rejected a true null hypothesis and lost your chance. It is a very serious problem because you could have been made for each other, but you didn't even try. Now, imagine another situation. She doesn't like you back, but you go and invite her out. The null hypothesis is still, she likes you back, but this time it is false. In reality, she doesn't really like you back, that is. However, after testing, you accept the null hypotheses and wrongly go and invite her out. She tells you that she has a boyfriend that is much older, smarter, and better at statistics than you and turns her back. You made a type 2 error, accepted a false null hypothesis. However, it is no big deal, as you go back to your normal life without her and soon forget about this awkward situation. Usually like that. You don't really want to make any of the two errors, but it happens sometimes. You should be aware that statistics is very useful, but not perfect. Alright, that's all from our love/life/statistics lesson. Thanks for watching. For more video.
I thought that was cute. All right. Good? Make sense? Type 1, type 2. All right, so let's just talk through these next couple examples. When you get to these on your Math Excel, it's going to be like drop-down menus, kind of filling in the phrases that are already pre-made for you, so we don't get too crazy with this. But in these situations, they're giving you a null hypothesis, and they want you to name what the type 1 and type 2 errors would be in this context. So in the first one, a bookstore claims that at least 60% of its customers will return to buy a book, to buy another book. So a type 1 error, if it's a type 1 error, are we assuming that it is true or false? Are we assuming that the null hypothesis is true or false if we have a type 1 error? Look at the chart if you need to. So we assume that it's true, or we know that it's true, but what happens? But we reject it as a true statement. Okay, so here it would be true that 60% of the customers would return to buy another book, but based on maybe our sample of customers that we use, we would determine this statement to not be true. So we would reject the bookstore's claim. Type 2, in real life, the statement is false. So the population of all bookstore customers, if we looked at that, would determine that this statement is not true. At least 60% do not come back to buy another book. But maybe we choose a sample of customers that all really do like to come back to that secondhand store. So we do not reject it, even though when it comes to the entire population, that is not a true statement. Does that make sense, how the sample you choose can sway that statement one way or the other? Depends who you ask to determine if it's going to be at least 60% or not. And the bigger your sample size, the less likely you are to make that error. Okay, same thing you could do for the one at the bottom here. A local chess club claims that the average length of time to play a game is 25 minutes. So a type 1 error would be that that statement is true. On average, it does take 25 minutes to play a game of chess. But your sampling and your data collection and your hypothesis test would reject that claim. We would say it's either a lot smaller than that or a lot bigger than that, so we would reject the chess club's claim. Type 2 would be if it does not actually take an average of 25 minutes to play a game, but our data tells us it does. So we do not reject something that is actually false. So however you want to word that. Okay? So think about it as true, false statements, if that helps. Again, when you get to Math Excel, these are going to be drop-down menus. So we're not going to get too much into it. All right, so that's all we really do with type 1 and type 2 errors. The other little chunk of this lesson we need to add on today now starts talking about level of significance. It mentioned in the video an alpha. So alpha is the level of significance that we use for any given hypothesis test. Sometimes they will tell you which alpha to use, and if you're making your own research, you get to choose the alpha. The alpha that you choose is going to be a small number, because the smaller the number, the less likely you are to make one of those errors, your type 1 error. So common levels of significance that we use are 0.1, 0.05, and 0.01. So those will pop up a lot. These obviously aren't the only ones, but those will come up more often than not. The probability of getting a type 2 error is beta. We don't really do a whole lot with beta. Beta, to calculate that, gets pretty complicated. So that would be something you would do in a higher level statistics class. But you might see it pop up. It's just the probability of getting a type 2 error. That's all you need to know with it. All right. When we make a hypothesis test, we are testing about a certain population parameter. We mentioned that yesterday. The ones that we will be testing for are our population mean and our population proportion. Now remember, we haven't done a whole lot of calculations with this, but we will when we get to section 7.4. Once you know the population parameter that you're testing, there's going to be a test statistic that goes along with it. So it's pretty much that same calculation from the sample versus the population, right? If we have a population mean, it's our mu. If we have a sample mean, it's our x bar. If we have a population proportion, it's p. If we have a sample, it's p hat we're going to use, and we'll see that in section 7.4. If we are calculating our mean, it's either a z or a t. So we'll use z's in 7.2, just like we did before. We use those first when we know the mean or the standard deviation of our population. And we use t when we do not know the standard deviation of our population. And when we get to p's, we'll actually use the z chart as well. So these are some decisions you're going to kind of make at the beginning of every hypothesis test. What are we testing? What's the test statistic? Which chart am I going to use? Is it going to be standard normal distribution, or is it going to be t-distribution based on whatever we're testing for? You can also do things with variance and standard deviation, but we haven't done a lot of that in this class. We don't really cover it, but it is something, again, in other statistics courses that you could calculate or test for. All right. Once we know what our test statistic is and whether we're going to use the standard normal distribution or the t-distribution, we can find p. P, our p-value or probability value, is going to be our probability of getting a sample statistic within a certain range. And we're going to find that in our z and our t charts. There are 3 different cases that you can have based on what your null and alternative hypothesis look like. Remember, there were 3 sets of those yesterday. The first case was if our null was greater than or equal to and our alternative was less than. If this is the case, you'll be looking at a probability to the left of whatever your standard statistic is, maybe a z-score, and we call that a left-tailed test. So when I look at these and I want to know if it's a left-tailed test or a right-tailed test or a two-tailed test, I look at the alternative hypothesis. So maybe if you want to circle that on your paper, the alternative here is less than k. And you can see that on the normal distribution here, it's less than a specific value. So if I saw that the alternative is less than, I know I need to use a left-tailed test. And then vice versa, case 2 is where my alternative is greater than, and we would use, in that case, a right-tailed test. And what you see shaded in blue here is that probability value, that p-value, that area that we're going to find on our z chart or our t chart. The third one is our equal to, not equal to scenario. And in this case, we'll be using areas to the left and to the right of certain test statistics. So we call this a two-tailed test. Remember that not equal to gives us a two-tailed test. And in each of these tails of my normal distribution curve, it is half of p. Okay. So what we're going to do on the last slide or 2 on your paper, says for each claim, we're going to state the null hypothesis and the alternative hypothesis in words. We'll do it in words. We'll write it in symbols. Then determine whether the hypothesis test is left-tailed, right-tailed, or two-tailed, and then we'll just sketch a little picture. Again, not a whole lot of math is going to be happening here. We'll start throwing all that in a little bit later on. All right, so a little bit review from yesterday. My claim. A school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. Okay, so I'm going to label it as my claim. It's a proportion, so it's a statement about P. And it says, well, what's it going to be? P equal to, not equal to, greater than, less than, equal to. What do you think based on this statement? Yep, is 61%. Now, what it's actually calculating are people that are in at least more than one or at least one extracurricular activity, but 0.61 is what we're actually calculating. Is that a null hypothesis or an alternative hypothesis? It is the null because it contains our statement of equality. which means the alternative hypothesis is P, what's the complement of that? Not equal to 0.61. So in words, it would be the proportion of students who are involved in at least one extracurricular activity is not 61%, if I wanted to put that in words. All right, so if my alternative hypothesis is not equal to, is it a left tail, a right tail, or a two-tailed test? It is a two-tailed test. And my P, my probability value, would be located in both tails. So each shaded region would be half of P. All right, can you guys try the second one on your paper? Write the null, write the alternative, which type of test it is, left, right, or two, and then sketch the p-value on your curve. So the claim is your alternative hypothesis that the mean is less than 15. So the null hypothesis, in words, we would say the mean is greater than or equal to 15 minutes for the oil change, which means it is a left tail test if my alternative hypothesis is less than, and your P then would be located to the left of whatever your standardized test statistic would be. That's where we're going to stop today. Okay, so we got time to work on Math Excel. You got like 20 minutes. Remember, you can do 7-1 part 1 and 7-1 part 2 now. If you want to do a little bit each day, those are due on Friday.